Tonight, we are going to talk about something that most people never stop to consider. Not about the stars we can see on a clear night, or the galaxies that telescopes have mapped in careful detail, or even the edges of what our most powerful instruments can reach. We are going to talk about everything else, the part of the universe that exists beyond any possible observation, the part that is already gone, not destroyed, not collapsed, not burned out, but simply moving away from us so fast that light itself cannot make the journey. We will never see it. No telescope built in any future era will ever change that. And the strange thing, the thing that takes a moment to settle, is that this hidden portion is not a small slice at the margins. It is most of the universe. You're listening to Sleepy Time Universe, calm science for curious minds seeking rest. There is something quietly remarkable about sitting with that idea. The universe we know, the one filled with galaxies and clusters and cosmic webs of matter, is only a thin shell of what actually exists. Beyond the boundary of what light can reach from our position, space continues. It continues in all directions, filled with the same kinds of structures, the same kinds of galaxies, perhaps an almost unimaginable number of stars and worlds, and we will never know them, not because of any failure of technology or imagination, but because the universe itself has a speed limit, and space has been expanding faster than that limit for a very long time. This video is an exploration of that boundary. We will move through it slowly, from the basic mechanics of light and distance, to the nature of expansion, to what it means for something to be permanently unreachable. There is no resolution at the end of this, no hopeful final discovery that changes the picture. But there is something else, a kind of deep stillness that comes from understanding the true scale of what surrounds us, and accepting that most of it will always remain, quietly and completely, beyond our reach. So find a comfortable position. Let the room settle around you. We have a long way to go tonight, and there is no reason to hurry. Chapter 1. Light has limits. Light is the fastest thing in the universe. That sentence is so familiar that it can pass through the mind without leaving much of an impression. We hear it early, in school or in a documentary, and we file it away as a known fact, something settled and unremarkable. But the speed of light is not just a record, it is a boundary. And like most boundaries, its true significance only becomes clear when you begin to trace what lies on the other side of it. Light travels through empty space at just under 300,000 kilometers every second. In a single second, a beam of light could circle the Earth more than 7 times. In 8 minutes, it crosses the distance from the Sun to our planet. In about 4 years, it reaches the nearest star beyond our own solar system. These numbers are already difficult to hold in the imagination, but they are only the beginning. The universe is not measured in years or decades. It is measured in billions of years of light travel, across distances so large that even the word vast begins to feel insufficient. When we look at a star, we are not seeing it as it is now. We are seeing it as it was, when the light we are currently receiving first left its surface. For nearby stars, that gap is a matter of years. For distant galaxies, the gap stretches into millions and then billions of years. The Andromeda Galaxy, the large spiral neighbor to our own Milky Way, appears to us as it was roughly 2.5 million years ago. We have no direct knowledge of what it looks like at this moment. The light carrying that information has not reached us yet. It is still traveling. This is not a flaw in our instruments. It is simply the nature of light and time. There is no way to receive information faster than light can carry it. And so every observation we make of the distant universe is, without exception, an observation of the past. The further we look, the further back in time we see. Our most powerful telescopes are, in a very real sense, time machines. They do not show us the universe as it is. They show us the universe as it was, at many different moments simultaneously, layered across the sky in all directions. This creates a picture of the cosmos that is composite and ancient. The nearby stars we see tonight left their light only a few years ago. The faint smudges of distant galaxies in a deep field image left their light hundreds of millions or even billions of years ago. And the farthest signal we have ever detected, the cosmic microwave background radiation that fills the entire sky in every direction, left its source nearly 14 billion years ago, when the universe was still young enough that no stars had yet formed, and matter and light had only just separated from one another for the first time. All of this is to say that we do not see the universe whole. We see it in fragments from different eras, assembled by our instruments into something that looks continuous, but is in fact a kind of deep archive, a library of light that left its sources at vastly different times, arriving here at our small position in space, carrying information about a cosmos that has already changed enormously since any of it was sent. And here is where the limit begins to matter in a different way, because light travels at a finite speed, and because the universe has a finite age, there is only so much light that could ever have reached us by now. The universe is approximately 13.8 billion years old. That means light has had 13.8 billion years to travel in our direction. Anything whose light would take longer than that to arrive simply has not reached us yet. Not because it does not exist, but because the journey is not yet complete. This defines something called the observable universe. It is not the whole universe. It is the portion from which light has had time to reach us since the beginning. It is the shell of space that we can, in principle, observe. Everything inside it we can study, at least in theory. Everything outside it remains beyond the reach of any signal, any wave, any particle moving at any speed. It is a horizon defined entirely by the age of the universe and the speed of light. And as we will begin to see in the chapters ahead, that horizon is not as generous as it might first sound. Chapter 2. Space itself expands. There is a distinction that takes a little time to settle, but once it does, it changes the way the rest of this story reads. The universe is not simply large, it is growing, and the way it grows is unlike anything we encounter in ordinary experience, because it is not objects moving through space that makes the universe expand. It is space itself that is stretching. To understand why this matters, consider the difference between two things moving apart from each other and the space between them growing. If two ships sail away from each other across an ocean, they are moving through the water. The water itself stays roughly the same. The distance between the ships increases because they are traveling. But in the universe, the situation is different. Galaxies that are far from us are not, for the most part, sailing through space under their own power in our direction or away from it. The space between us and them is expanding. The fabric of the cosmos is stretching, and everything embedded in it is being carried along. This was first understood observationally in the early decades of the 20th century. Astronomers studying distant galaxies noticed something unusual in the light arriving from them. The light was shifted toward the red end of the spectrum, and the further away a galaxy was, the more pronounced this shift appeared to be. This redshift was not random. It followed a pattern. Galaxies at greater distances showed greater shifts, and the relationship between distance and shift was remarkably consistent. The interpretation that emerged from this data was striking. The galaxies were not simply moving away from us through space. The space between us and them was stretching, and as it stretched, the wavelengths of light traveling through it were being stretched along with it. Light that began its journey at one wavelength arrived at a longer one. That lengthening pushed the light toward the red end of the spectrum. The further the light had traveled, the more the space it crossed had stretched during its journey, and the more its wavelength had been pulled. This gave astronomers a way to measure the expansion. By studying the degree of redshift in a galaxy's light, they could estimate how much space had expanded between that galaxy and us since the light was emitted. And what they found, gradually, and then with increasing precision over the following decades, was that the universe had been expanding continuously since its earliest moments. Not from a point in space, as though something had exploded outward from a center, but everywhere at once. Every region of space stretching away from every other region, in all directions simultaneously. The implication of this for our understanding of cosmic distance is significant. When we say that a distant galaxy is, for example, 13 billion light-years away, we are describing the distance that light has traveled to reach us. But during those 13 billion years, the space between us and that galaxy has continued to expand. The galaxy is now much further away than 13 billion light-years in terms of its actual current position. It has been carried by the expansion of space to a location considerably more remote than where it was when the light we are receiving first left it. This is a subtle but important point. The observable universe has a radius of about 46 billion light-years in terms of current distance, even though the universe is only about 13.8 billion years old. The difference comes from expansion. The matter that emitted the oldest light we can detect was much closer to us when that light was emitted, but it has since been carried outward by the growth of space to its present position, roughly 46 billion light-years away from us today. Now consider what this means for the universe beyond that boundary. Space beyond the observable horizon has also been expanding, and expanding continuously. The galaxies and structures that lie beyond our cosmic horizon are not stationary. They are being carried outward by the same expansion that moves everything else. And crucially, for a very large portion of the universe, the rate at which space is expanding between us and those distant regions is faster than light can travel. That last sentence deserves a moment of quiet attention. Space can expand faster than light. This does not violate the rules of physics, because nothing is moving through space at that speed. Space itself is simply growing, and there is no upper limit on how fast it can do so. The speed of light is a limit on motion through space. It is not a limit on the growth of space itself. And in a universe that has been expanding for nearly 14 billion years, and that appears to be accelerating in that expansion, vast regions of space are receding from us at rates that light cannot match. This is what transforms the cosmic horizon from a temporary gap into a permanent one. If the expansion of space were slowing down, we might eventually receive light from regions that are currently beyond our reach. Given enough time, that light might close the distance, but the expansion is not slowing. It is speeding up, and that changes everything about what we can and cannot expect to ever see. We will come to that acceleration in more detail shortly. But first, it is worth sitting with the picture as it stands. Space is expanding in all directions. The further away a region is, the faster it is receding. And beyond a certain distance, it is receding faster than any signal can follow. Chapter 3. The Horizon We Cannot Cross. Every observer in the universe has a horizon, not a visible line on the ground, not a boundary marked in any physical way, but a limit nonetheless, a distance beyond which no information has ever arrived, and beyond which no information ever will. We call this the cosmic horizon, or more precisely the cosmological event horizon, and it is one of the most consequential features of the universe we inhabit. The word horizon is a good one for this, because it carries the right implication. A horizon is not a wall. It is not a place where space ends or where something different begins. It is simply the furthest point from which something can be seen from a given position. Stand on a flat plane, and the horizon is the furthest point your eyes can reach before the curvature of the Earth carries the ground out of your line of sight. Move toward the horizon, and it moves with you. It is always relative to where you are standing. The cosmic horizon works in a similar way. It is defined by your position in space and by the physics of expansion. From Earth, our cosmic horizon is the boundary beyond which the recession of space exceeds the speed of light. Galaxies on the far side of that boundary are moving away from us faster than light can travel, which means any light they emit in our direction will never reach us. It will spend its entire existence trying to cross an expanding gap that only grows wider. The photons will travel for billions of years and make no net progress toward us at all. This is the horizon we cannot cross. Not with spacecraft, not with signals, not with any physical process that relies on moving through space. It is a permanent feature of our position in an accelerating universe. What makes this horizon different from the simple edge of the observable universe is the role that acceleration plays. If the universe were expanding at a constant rate, the horizon would still exist, but its future behavior would be different. Light emitted today from just beyond the horizon might, given enough time, eventually make its way to us if the expansion rate remains stable. The math would be tight, but not impossible. However, we do not live in a universe with a constant expansion rate. We live in one where the expansion is speeding up, driven by something we call dark energy, a property of space itself that appears to push outward with increasing effect as time passes. Because of this acceleration, the horizon is not only a present boundary, it is a shrinking one. Over time, as the expansion accelerates, galaxies that are currently within our observable universe will eventually cross our horizon and recede beyond it. Their light will redshift further and further, stretching to wavelengths too long to detect, fading from any possible observation. They will not disappear in a dramatic sense. They will simply drift beyond the point where their light can reach us, and then they will be gone from our sky forever. Astronomers have estimated that roughly 100,000 million galaxies currently exist within our observable universe. That number is already difficult to hold in the mind, but the number of galaxies that lie beyond the observable boundary in the portion of the universe we will never see is almost certainly far larger. Our observable region is one patch in a much greater whole, and that whole continues in every direction without any known edge. There is a version of this idea that some find unsettling, and others find quietly calming. We are not at the center of the universe in any special sense. Every point in space has its own horizon, its own observable bubble, its own region of permanent visibility surrounded by regions of permanent invisibility. An observer in a galaxy billions of light years from here would have their own horizon, overlapping partially with ours, but extending in directions we cannot see. They would observe galaxies we will never know, and be forever blind to others that we can study in detail. The universe is, in this sense, made of countless individual perspectives, each enclosed in its own bubble of knowable space, none of them complete. There is something in that image that invites a kind of stillness, not sadness exactly, though it has a melancholy quality, more like the feeling of standing at the edge of a very large landscape and understanding, without any distress, that you will not see all of it. The landscape is still there. Its existence does not depend on your observation of it. The galaxies beyond the horizon are real, structured, evolving, perhaps filled with complexity we cannot guess at. They simply exist outside the reach of any signal we could ever send or receive. The horizon is not a wall. It is a quiet limit, and quietly, it defines the shape of everything we will ever know. Chapter 4. Dark energy accelerates everything. For most of the 20th century, the prevailing assumption among cosmologists was that the expansion of the universe was slowing down. This seemed reasonable. Gravity is the dominant force on large scales, and gravity pulls matter together. The galaxies and clusters spread across the universe exert gravitational attraction on one another, and that attraction should, over time, act as a brake on the outward expansion that began at the universe's earliest moments. The question was not whether the expansion was decelerating, but by how much, and whether it would eventually halt and reverse. In the final years of the 20th century, two independent teams of astronomers set out to measure that deceleration precisely. They used a particular type of exploding star, a supernova of a kind known as Type 1a, as a standard reference point. These supernovae are useful for distance measurement because they always explode with approximately the same intrinsic brightness. By comparing how bright they appear from Earth against how bright they should be, astronomers can calculate how far away they are with considerable precision. The teams studied supernovae at great distances, expecting to find the subtle signature of a universe slowing under its own gravitational weight. What they found instead was the opposite. The distant supernovae were fainter than expected, not brighter, which would have indicated they were closer than predicted, but fainter, meaning they were further away than the models had anticipated. The universe was not decelerating, it was accelerating. The expansion was not being pulled back by gravity, it was speeding up. This result was so unexpected and so difficult to reconcile with existing models that both teams spent considerable time checking and rechecking their data before publishing. When the findings were eventually released in 1998, they overturned one of the central assumptions of cosmology. The universe was not coasting toward a gentle slowdown. Something was actively driving it to expand faster and faster with the passage of time. That something was given the name dark energy. It is a placeholder, in a sense, a label for a phenomenon that has been measured with increasing precision, but whose underlying nature remains one of the deepest unsolved problems in all of physics. Dark energy appears to be a property of space itself. As space expands and more space comes into existence, the total amount of dark energy increases proportionally, and its outward pressure grows. This creates a self-reinforcing process. More expansion produces more dark energy, which drives further expansion, which produces still more dark energy. The result is an acceleration that compounds over time. Current measurements suggest that dark energy accounts for approximately 68% of the total energy content of the universe. Ordinary matter, the stars, planets, gas, dust, and everything built from atoms, accounts for only about 5%. The remaining 27% is dark matter, a separate mystery, a form of mass that interacts gravitationally but does not emit or absorb light. Together, dark energy and dark matter make up the overwhelming majority of what the universe contains, and both remain fundamentally unexplained at the level of what they actually are. For our purposes in this video, the significance of dark energy is specific. It is the engine of acceleration. It is the reason the cosmic horizon is not merely a present boundary, but a tightening one. In a universe without dark energy, or with a dark energy that remained constant or decreased over time, the future of cosmic observation might look different. Distant regions might eventually become reachable as expansion slowed. Light from beyond the current horizon might gradually work its way toward us. But dark energy does not appear to be weakening. Every indication from current data suggests it is either constant or increasing. And that means the acceleration is here to stay. The practical consequence of this acceleration for cosmic visibility is stark. Galaxies that are currently close to our horizon will, over billions of years, cross it and disappear from any possible observation. Their light will redshift toward infinitely long wavelengths, fading beyond any detector. They will become, in the most complete sense, unreachable and unknowable from our position. And the process will continue, drawing the horizon slightly closer over vast timescales, leaving the universe we can observe gradually but permanently smaller. There is a thought experiment that some cosmologists have explored, which is worth pausing on here. Imagine a civilization that exists not now, but in the very distant future, perhaps 100 billion years from now. By that point, the Milky Way and its nearest neighbors will have merged into a single large galaxy. Beyond that merged structure, the accelerating expansion will have carried all other galaxies so far away that their light will no longer be detectable. The cosmic microwave background radiation will have redshifted to wavelengths far too long to measure with any conceivable instrument. That future civilization, looking out at its sky, would see only its own galaxy and darkness beyond. It would have no observational evidence that other galaxies had ever existed. It would have no way to detect the expansion of space, because there would be nothing left in its observable universe to use as a reference point. That civilization would look at the sky and conclude, reasonably and incorrectly, that the universe consisted of a single galaxy surrounded by infinite empty space. All of the evidence that would allow a different conclusion, the redshifts, the distant galaxies, the cosmic background radiation, would be gone. Not hidden, gone, carried beyond any possible horizon by an acceleration that had been running for billions of years before that civilization ever existed. We are fortunate, in a quiet way, to exist at a time when the evidence is still visible, when the horizon is far enough away that telescopes can gather light from billions of galaxies and construct a picture of the cosmos that actually reflects its large-scale structure. Future observers may not have that opportunity. The window is open now, and the universe beyond it is already, mostly, out of reach. Chapter 5. What light cannot reach? There is a particular kind of distance that has no equivalent in everyday life. Not the distance between cities, or between continents, or even between planets. Those distances are large, but they are crossable in principle. Given enough time and energy, a traveler could cover them. The distances we are now considering are different in kind, not just in degree. They are distances that cannot be crossed regardless of how much time passes or how much energy is applied, because the space between here and there is growing faster than any traveler or signal could ever move. To appreciate what this means, it helps to think carefully about what light does when it enters an expanding universe. A photon emitted from a distant galaxy begins its journey moving at the speed of light through local space. But local space is itself being carried along by the expansion. The photon is swimming in a current, and depending on where it starts, the current may be moving against it faster than it can swim. A photon emitted from a galaxy that is currently receding from us faster than light will never reach us. It will travel in our direction for its entire existence and never close the gap. The expansion of space between us and that photon will always outpace its motion toward us. This is the region we are talking about when we describe what light cannot reach. It is not empty. It is not featureless. It is filled with the same structures that populate the observable universe. Galaxies, clusters, filaments of matter stretching across enormous scales, and within all of that, stars and the worlds that circle them. Everything that exists in our observable region almost certainly has its counterpart in the regions beyond the horizon. The physics that governs matter and energy does not stop at our cosmic boundary. The universe continues, structured and active and indifferent to the fact that we cannot see it. What we lose beyond the horizon is not the existence of these things. We lose all access to information about them. In physics, information travels by signals, and all signals are limited by the speed of light. A gravitational wave, a beam of radio emission, a pulse of visible light. All of these move at the same ultimate speed, and all of them are subject to the same horizon. There is no privileged channel through which information from beyond the boundary could arrive. The horizon applies equally to everything. This has a subtle but significant philosophical implication. Science is built on observation. We form hypotheses, we make predictions, and we test those predictions against measurements of the physical world. For everything within the observable universe, this process can in principle be applied. We can gather light, analyze it, draw conclusions, and refine our understanding. For everything beyond the horizon, none of that is possible. We cannot observe it, measure it, or test any hypothesis about it against direct evidence. It exists, almost certainly, but it exists in a domain that is permanently closed to empirical investigation from our position. Some physicists and cosmologists find this deeply uncomfortable. Science has always proceeded by extending its reach, by building instruments sensitive enough to detect what was previously undetectable, by developing theories powerful enough to describe what was previously unexplained. The cosmic horizon represents a limit that cannot be pushed back by any advance in technology or theory. It is not a gap in our knowledge that future generations will fill. It is a permanent feature of the universe we inhabit, a sealed door with no key. Others find a different quality in it. There is something clarifying about a genuine limit. It tells us where we actually stand. It defines the scope of what is knowable from here, not as a failure of understanding, but as an honest description of our position in a very large and very old cosmos. We are observers in a particular location, at a particular moment in the history of the universe, and our horizon is the shape of what that position allows us to see. That shape is not small. The observable universe contains hundreds of billions of galaxies, each containing hundreds of billions of stars. The knowable portion of the cosmos is already more than any mind can fully absorb. The fact that it is not everything does not diminish what it is. And yet, the light that will never reach us is still traveling. Somewhere beyond the horizon, photons are moving in our direction that were emitted billions of years ago by stars we will never know existed. They are making a journey that has no destination. They will travel for the entire remaining lifetime of the universe, growing ever more redshifted as the space around them expands, carrying information about galaxies and events that no observer anywhere near us will ever receive. They are messages sent into a silence that will never be broken. There is something in that image that deserves a moment of quiet attention. Not distress, not loss in any personal sense, but a kind of recognition of scale. The universe is sending signals that no one will ever read. It is full of light that will never illuminate anything. And it continues doing this with complete indifference, because indifference is simply what the universe is. It does not withhold. It does not conceal. It simply expands. And in expanding, it places most of itself permanently beyond the reach of anyone standing where we are standing. That is not a tragedy. It is a description. And descriptions, even the vast and humbling ones, have a way of settling the mind. Chapter 6. The Universe's True Size. One of the more disorienting facts in all of cosmology is that the observable universe, the portion we can in principle see, is not the same size as the universe itself. These two things are often conflated, and the conflation is understandable, because for most practical purposes we treat the observable universe as the universe. It is everything we can measure, map, and study. But it is not everything that exists. It is a bubble within something far larger, and the size of that larger something is, by any honest account, unknown. The observable universe has a radius of approximately 46 billion light-years in all directions from our position. This gives it a diameter of roughly 93 billion light-years. That figure already exceeds most attempts at comprehension. If you were to represent the entire observable universe as a single grain of sand, the distance from that grain to the nearest other grain on the same scale would exceed the width of the Milky Way. The numbers involved in cosmic distance are not just large. They are large in a way that defeats ordinary intuition entirely. And yet, this observable bubble, incomprehensibly vast as it is, represents only a fraction of the whole. The question of how large the whole universe actually is has no settled answer. Cosmologists approach it from several directions, and the conclusions they reach are, in their own way, more staggering than the observable figures. One approach comes from the geometry of space. The observable universe appears, from every measurement we have made, to be geometrically flat. This means that the angles of a very large triangle drawn across cosmic distances would add up to exactly 180 degrees, just as they do in the flat geometry we learn in school. A universe that is perfectly flat in this sense is, mathematically, infinite. It has no edge, no boundary, and no center. It simply continues in all directions without limit. If the universe is truly infinite, then the question of how much of it lies beyond our horizon has a straightforward answer: an infinite amount. Every kind of structure that can exist under the laws of physics exists somewhere in an infinite universe, and exists infinitely many times. Every configuration of matter, every arrangement of galaxies, every possible sequence of events that is consistent with physical law is not just possible, but actual, repeated endlessly, across a space that has no boundary. That is a conclusion that follows directly from the mathematics of infinite flat space, though it sits uncomfortably with most human intuitions about what the word real means. Not all cosmologists are comfortable with the infinite universe interpretation, and there are good reasons for caution. The flatness we measure is the flatness of the observable region. We cannot directly measure the geometry of the universe beyond our horizon. It is possible, in principle, that the universe curves back on itself at scales far larger than our observable bubble, the way the surface of a sphere curves back on itself, producing a finite but unbounded space. In that case, the universe would have a definite size, just a very large one. Current measurements cannot distinguish between these possibilities with certainty. The universe could be infinite, or it could be finite and simply vastly larger than what we can see. Some estimates have attempted to place a lower bound on the total size of the universe, based on the constraints from our measurements of flatness. These estimates suggest that even if the universe is finite, it must be at least several orders of magnitude larger than the observable portion. Some calculations place the lower bound at hundreds of times the diameter of the observable universe. Others suggest thousands of times. And if the universe is indeed infinite, then all of these figures are simply steps on a ladder that has no top rung. What this means for the hidden portion of the universe is significant. The observable universe is not a large fraction of the whole with a small remainder tucked beyond the edges. It is, almost certainly, a vanishingly small fraction of everything that exists. The ratio of what we can see to what exists beyond our horizon is not 1 to 2, or 1 to 10, or even 1 to a million. It is, in all likelihood, incomprehensibly small. We occupy a bubble of knowable space that floats in a totality so large that the bubble itself is, by comparison, essentially nothing. This is not a comfortable thought to sit with for too long, but it is worth sitting with briefly because it reframes the ordinary experience of looking at the night sky. When we look at the stars, we are looking at the observable universe. We are looking at everything our position in space and time allows us to see. And that view, rich and deep and filled with more structure than any lifetime could fully explore, represents only the thinnest imaginable sliver of what actually exists. The rest is out there, structured, evolving, real in every physical sense. Galaxies forming and dying, stars burning through their fuel, matter assembling and dispersing across scales we cannot guess at. None of it sending us any signal we can receive. None of it visible in any telescope, detectable by any instrument, reachable by any signal we could send. It is the universe being the universe, completely and without any reference to our ability to observe it. There is a kind of freedom in that, if you let yourself feel it. The universe does not need to be seen to exist. It does not require our instruments or our attention or our understanding. It proceeds on its own terms, in its own time, across distances that have no practical meaning for any creature of our size and lifespan. We are very small and very local, and the universe is under no obligation to fit within the boundaries of what we can know. The fact that so much of it lies beyond our horizon is not a problem to be solved. It is simply the shape of things. Chapter 7. Galaxies already leaving. There is a particular category of galaxy that deserves careful attention in any discussion of the cosmic horizon. These are not the galaxies at the very edge of the observable universe, the ancient and distant objects whose light has been traveling toward us since the universe was young. Those galaxies are already beyond practical reach in every meaningful sense. The category I want to describe here is closer than that, and in some ways more affecting. These are galaxies that are currently within our observable universe, galaxies we can see and study right now, that are in the process of crossing our cosmic horizon. They are leaving, not dramatically, not in any way that would be visible to a human observer watching in real time, but inexorably and permanently, carried beyond the boundary by the accelerating expansion of space. The process by which this happens is gradual but inevitable. As dark energy continues to drive the expansion of space at an accelerating rate, the recession velocity of distant galaxies increases over time. A galaxy that is currently receding from us at just below the speed of light, sitting near the edge of our observable region, will over billions of years be pushed further and further away. Its recession velocity will creep above the speed of light as more space opens up between us and it. At that point, the light it emits in our direction will begin to lose ground. The photons will still be traveling toward us, but the space they are crossing will be expanding faster than they can move through it. Eventually, the light will make no net progress at all, and then, over still longer timescales, it will effectively be carried backward, never to arrive. From our perspective, the galaxy does not vanish instantly. The last light it ever sends us will arrive stretched to extraordinary lengths, redshifted far beyond the visible spectrum, fading over an immense span of time into wavelengths too long and too faint to detect with any instrument. The galaxy will appear to slow in its recession, freeze at the horizon, and then simply cease to contribute any observable signal. It will be as though it never existed, because all evidence of its existence will have passed beyond any possible detection. Astronomers have calculated that the galaxies currently sitting at the boundary of the observable universe are not the only ones destined to cross it. Many galaxies that are presently well within our observable region will, given enough time, also drift beyond the horizon. The local group, the small collection of galaxies that includes the Milky Way and its nearest neighbors, will remain gravitationally bound together and will not disperse. Gravity on local scales is strong enough to hold these structures together against the expansion of space. But beyond the local group, beyond the gravitationally bound clusters and superclusters of galaxies, the expansion will continue to pull everything away. On timescales of tens of billions of years, the sky as seen from Earth, or from whatever remains in this region of space, will gradually empty of all galaxies beyond our immediate neighborhood. One by one, over spans of time that dwarf the current age of the universe, the distant galaxies will cross the horizon and disappear from any possible observation. The cosmic web, that vast network of filaments and voids that structures the universe on the larger scales, will become invisible, not because it ceases to exist, but because the light carrying information about it can no longer reach us. What remains visible in that distant future will be the merged remnant of the local group, a large elliptical galaxy formed from the collision and combination of the Milky Way, the Andromeda Galaxy, and the smaller satellites that accompany them. Beyond that merged structure, the sky will be dark. Not the dark of a night sky filled with stars too faint to see clearly, but a genuine and total darkness, unbroken by any external galaxy, unmarked by any cosmic structure that could hint at the universe's true scale. It is worth pausing to think about what knowledge would be available to observers in that future era. They would be able to study their own galaxy in enormous detail. They would be able to observe stellar evolution, map the distribution of matter within their gravitational neighborhood, and develop an extremely detailed understanding of physics on scales up to a few million light years. But beyond that boundary, there would be nothing to observe. No redshifts to measure, because there would be no distant galaxies to measure them from. No cosmic microwave background, because it would have redshifted to wavelengths far below any conceivable detection threshold. No evidence of expansion, because there would be no external reference points against which to measure it. Those future observers would be in the position of someone trying to understand the size of a continent from a single room with no windows. They would have access to extraordinary detail about their immediate surroundings and complete blindness to everything beyond. They might develop theories about a larger universe, drawing on mathematical reasoning and the internal logic of their physics, but they would have no observational data to test those theories against. The empirical foundation of cosmology, the actual measurement of the universe's structure and history, would be gone. We do not face that situation yet. We are living in what some cosmologists have described as a golden age of cosmic observation, a period when the universe is old enough to contain rich structure, but young enough that much of that structure is still within our observable horizon. The evidence for expansion, for the cosmic history of the universe, for the large-scale structure that tells us so much about how everything came to be. All of it is still visible. All of it is still accessible. But the window is not permanent. The galaxies are leaving, one by one, carried beyond the horizon by a force that has no intention and no awareness, simply the quiet, relentless pressure of dark energy pushing space outward in every direction at every moment. They do not know they are leaving. They are simply going, as everything in the universe eventually goes, beyond the reach of anyone watching from here. Chapter 8. Other bubbles, other skies. Every point in space has its own horizon. This is one of those facts that sounds simple, but opens into something much larger the longer you consider it. An observer in a galaxy 10 billion light-years from here, in a direction we can barely see, even with our most powerful instruments, looks out at their own observable universe. Their bubble of knowable space overlaps with ours in some regions. There are galaxies that both they and we can observe, sitting in the overlap between our two horizons. But their bubble also extends in directions that ours does not reach, taking in regions of the universe that are permanently invisible to us and will always remain so. This means the universe is not experienced the same way from every location. Each observer, each civilization, each instrument pointed at the sky from any position in space is working with a different portion of the whole. No two positions share exactly the same observable universe, and for observers separated by distances large enough, the overlap between their observable regions becomes zero. Their bubbles of knowable space are entirely distinct, with no galaxies in common, no shared history visible to both, no overlapping evidence from which a combined picture of the cosmos could ever be assembled. There are, in this sense, regions of the universe that are permanently isolated from one another, not by walls or barriers, but simply by distance and the finite speed of light operating within an accelerating expansion. Whatever is happening in those regions, whatever structures exist there, whatever processes are unfolding across scales we cannot guess at, none of it will ever be communicated to us, and none of our existence will ever be communicated to them. We share a universe in the sense that the same physical laws apply everywhere, and in the sense that everything ultimately traces back to the same origin. But we do not share a universe in any observational sense. The cosmos is, at sufficient scale, a collection of permanently separated perspectives, each enclosed in its own horizon, each blind to most of what exists. This idea connects to something that some physicists have explored under the name of the multiverse, though that word carries many different meanings depending on the context. In the most conservative interpretation, the existence of regions beyond our horizon that we can never observe is simply a feature of our universe, not a separate universe in any exotic sense. The space beyond our horizon is the same space we inhabit, governed by the same laws, continuous with our own region. It is simply unreachable. Other horizon bubbles are other perspectives on the same universe, not separate realities. What those other perspectives contain is a question that physics can approach only indirectly. If the universe is infinite and uniform on large scales, as current evidence suggests it may be, then the structures in other horizon bubbles should be broadly similar to our own. Galaxies, clusters, filaments, voids. The same large-scale architecture repeated across space without any known boundary. In an infinite universe, every possible arrangement of matter that is consistent with physical law exists somewhere. There are, somewhere beyond our horizon, regions that look very similar to our own. There may be regions where the distribution of galaxies closely mirrors what we observe from here. The mathematics of infinite space leads to these conclusions without any mysticism or speculation. It is simply what infinite repetition implies. Sitting with that idea has a particular quality. Somewhere, unreachably far away, the same arrangement of matter that produced this galaxy, this star, this planet, this moment, may be repeated. Not because the universe is designed to produce repetition, but because in a space large enough, all arrangements eventually recur. We cannot verify this. We cannot observe it. We cannot test it against any data. But it follows from the same geometry that describes the universe we can see, extended to scales we cannot reach. Consider what it means to exist at a particular point in this vast arrangement of perspectives. Every civilization that has ever looked at the sky, anywhere in the universe, has done so from within its own horizon bubble. Every map ever drawn of the cosmos, every catalogue of galaxies, every measurement of the expansion rate, every photograph of deep space, all of it produced from within a local bubble of knowable space, representing a tiny fraction of what exists. This is not a limitation unique to us. It is the condition of all observers everywhere. The universe grants each perspective a window, and the window is always partial, always local, always finite. What varies between those windows is their content. An observer positioned in a region of the universe where galaxies are more densely clustered might look out at a richer sky, more populated with visible structure. An observer in a void, a large underdense region between galaxy filaments, might look out at a sky that appears emptier than ours. Neither perspective is more correct than the other. Both are honest observations of what their particular window reveals. The universe has no preferred vantage point, no location from which it can be seen whole. It is too large for that. It has always been too large for that, and it grows larger, in the only sense that matters for observation, with every passing moment as the expansion carries more of it beyond every possible horizon. That unreachable repetition, that quiet echo of our own existence somewhere beyond any possible horizon, is perhaps the most humanly affecting implication of everything we have been exploring in this video. The universe is not just large. It is so large that our entire observable region, with all its hundreds of billions of galaxies, is a local phenomenon, a neighborhood, a small and temporary window onto something that extends, in all likelihood, without end. Chapter 9. What Science Cannot Answer. There is a boundary that science reaches before the cosmic horizon does, and it is worth being clear about where that boundary sits. The horizon we have been describing throughout this video is a physical limit, a constraint imposed by the speed of light, the age of the universe, and the accelerating expansion of space. But there is a second kind of limit that runs alongside it, quieter and less often discussed, which is the limit of what empirical investigation can meaningfully address. Science proceeds by observation and measurement. A hypothesis is formed, predictions are derived from it, and those predictions are tested against data gathered from the physical world. This method has proven extraordinarily powerful. It has taken us from candles and compasses to telescopes that can detect the light of galaxies formed within the first billion years of cosmic history. It has given us a detailed account of the universe's origin, structure, and evolution that would have seemed like fantasy to any observer living only a few centuries ago. The reach of science, applied patiently and rigorously over generations, is genuinely remarkable. But the method depends on data. Without observations to test predictions against, the scientific process stalls. it can continue to produce internally consistent mathematical frameworks, elegant theories that extend known physics into unknown territory. But those frameworks, however beautiful or logically compelling, remain unverified until they make contact with measurement. And beyond the cosmic horizon, measurement is impossible. No data will ever arrive from those regions. No observation will ever confirm or refute any claim about what exists there. This places a genuine and permanent constraint on cosmology as an empirical science. Questions about the total size of the universe, the number of galaxies beyond the horizon, the distribution of matter across scales larger than our observable bubble, the question of whether the universe is truly infinite or merely very large. None of these can be answered by observation. They can be approached through mathematical reasoning, through extrapolation from what we do observe, through theoretical frameworks that are consistent with our data but extend beyond it. But they cannot be settled empirically. They sit in a space between physics and philosophy, where the tools of science can point in a direction but cannot deliver a final answer. Some scientists are comfortable with this situation, and others find it deeply unsatisfying. The discomfort is understandable. Science has historically expanded its reach by developing better instruments and more sensitive methods. There has always been the possibility that what was previously undetectable would eventually become detectable with sufficient ingenuity. The cosmic horizon feels different because it is not a technological limitation. It is a fundamental one. No improvement in instruments will push it back. No theoretical breakthrough will allow signals from beyond it to reach us. It is fixed by physics itself, and physics, in this case, is not negotiable. What remains within the reach of science is still extraordinary. The observable universe contains enough structure, enough history, enough unanswered questions to occupy cosmology for as long as the discipline exists. The nature of dark energy, the properties of dark matter, the precise mechanisms of the earliest moments of cosmic history, the question of whether life exists elsewhere in the observable universe. These are all open problems of enormous depth and richness, all accessible in principle to observation and measurement. The existence of the horizon does not impoverish science. It defines its territory, which is already vast beyond any practical limit. But the questions that sit beyond the horizon have a different character, and they deserve acknowledgement as a different kind of question. They are not scientific questions in the operational sense, because they cannot be tested. They are questions about the nature of existence at scales larger than any possible observation. They are, in the oldest and most honest sense of the word, philosophical. And philosophy has always been the place where human inquiry goes, when it reaches the edge of what can be directly known and still needs to keep thinking. The universe beyond our horizon exists. Almost certainly it exists, and almost certainly it is, rich with structure and complexity. But its existence is known to us not through measurement, but through reasoning, through the application of physical laws that we have tested within our observable region, extended outward by inference into territory we can never directly examine. That inference is well-founded. It is the best we can do, and it is, in its own way, a remarkable thing that creatures of our size, on a small planet orbiting an ordinary star, can reason their way to a reliable description of a universe that extends far beyond anything they will ever see. There is a long tradition in human thought of sitting with questions that cannot be fully resolved. Not every inquiry ends in a clean answer. Some of the most important questions ever asked have led not to conclusions, but to a deeper understanding of why the question is hard, and what that difficulty reveals about the nature of the thing being asked about. The cosmic horizon is one of those questions made physical. It is the universe's own way of showing us where knowing ends and wondering begins. And wondering, done quietly and without urgency, is not so different from the kind of rest that comes when the mind finally stops reaching and simply settles into what is. We have mapped the territory of the knowable as far as it goes. We have traced the boundary carefully, from the speed of light to the mechanics of expansion to the permanent silence beyond the horizon. What lies on the other side of that boundary is not nothing. It is everything we cannot see, and that everything, vast and unhurried and indifferent to our curiosity, continues on its own terms, as it always has, as it always will, whether or not any mind is present to wonder about it. Chapter 10. Resting at the Edge. There is a particular kind of peace that comes from reaching the edge of something genuinely large. Not the restlessness of incompleteness, not the frustration of a question left unanswered, but something quieter and more settled. The peace of having followed a line of thinking all the way to where it naturally ends, and finding that the ending is not a wall, but an opening. A place where the known gives way to the simply unknowable, and where that unknowability feels less like a loss and more like a reminder of scale. We have traveled a considerable distance in this video. We began with light, and with the simple but profound fact that it moves at a finite speed through a universe that has existed for a finite time. We followed that fact to its conclusion, that there is only so much of the cosmos from which light has had time to reach us, and that everything beyond that reach is permanently hidden, not by any failure of technology or imagination, but by the fundamental geometry of space and time in an expanding universe. We looked at the expansion itself, at the way space stretches in every direction simultaneously, carrying galaxies away from one another, not because they are moving through space, but because space itself is growing between them. We considered what it means for that expansion to be accelerating, driven by a dark energy whose nature remains one of the deepest unsolved problems in physics, and how that acceleration transforms the cosmic horizon from a present boundary into a tightening one, drawing the observable universe gradually but permanently smaller over timescales that dwarf anything in human experience. We thought about the galaxies that are already leaving, carried beyond the horizon one by one over billions of years, their light fading to wavelengths too long to detect, their existence eventually erased from any possible observation. We considered the future observers who will inherit a sky emptied of all external galaxies, with no way of knowing what their predecessors once saw, no evidence remaining of the vast cosmic structure that once filled every direction of the sky with light. We explored the true size of the universe and the humbling likelihood that our observable bubble, incomprehensibly vast as it is, represents only an infinitesimal fraction of everything that exists. We considered the other bubbles, the other horizons, the other observers at other positions in space, looking out at their own partial windows onto a cosmos that no single perspective can ever see whole. And we traced the boundary of what science can answer, finding that the horizon is not just a physical limit, but an epistemological one, a place where empirical inquiry gives way to reasoning, and reasoning gives way to wonder. What remains at the end of all of this is not a resolution. The universe beyond the horizon does not reveal itself simply because we have thought carefully about it. The expansion does not pause. The dark energy does not relent. The light that will never reach us continues its journey through space that grows wider with every passing moment, carrying information about galaxies and stars and whatever else exists out there, information that will never be read by any mind positioned where we are positioned, and yet There is something deeply restful in that picture, if you allow yourself to settle into it rather than resist it. The universe is not withholding anything from us. It is simply being what it is, vast, expanding, indifferent, and real in every direction beyond any boundary we can draw. The hidden portion is not hidden because it is secret. It is hidden because distance and time and the speed of light have arranged themselves in a particular way, and that arrangement places most of the cosmos beyond our reach. There is no malice in it, no mystery designed to frustrate. It is simply the shape of things, as honest and as quiet as the night sky itself. We are very small. We occupy a very specific moment in the history of a universe that has been running for nearly 14 billion years and will continue running for far longer than that. Our observable region is a temporary window, already beginning to shrink at its edges as distant galaxies cross the horizon one by one. The evidence that would allow future observers to understand the universe as we understand it is already fading. The window we have now, the view of a cosmos rich with structure and history and the faint afterglow of its own beginning, is not permanent. It is a gift of timing, available to those who exist at this particular moment in cosmic history, and not to those who will come after. That is worth sitting with gently, without urgency. We are here at a time when the universe can still be seen, when the light is still arriving, when the horizon, though it cannot be crossed, is far enough away that we can study what lies near it and reason carefully about what lies beyond. We have instruments sensitive enough to detect the oldest light in the universe. We have mathematics powerful enough to describe the geometry of space on scales that no human will ever physically travel. We have, in short, a remarkable view. Partial, local, temporary, but genuine. The rest of the universe is out there, structured and silent, expanding and unhurried, carrying on without any need for our awareness of it. Most of it is already beyond reach. Most of it has always been beyond reach. And somehow, that is not a diminishment of what we have. It is simply the context in which we have it. A small and quiet position at the edge of the knowable, looking out at the light that made it this far, grateful in whatever way a mind can be grateful that any of it arrived at all. If this was a good companion tonight, a like or a subscribe helps other curious minds find their way here.